The Brussels Photonics team has a pioneering role in the use of absorption spectroscopy to study ancient glasses. One example is the use of photonics to investigate stained glass windows. These could be either monumental windows, or this could also be individual pieces that originally formed part of a larger window. The study of those windows is quite challenging because they are either still preserved in situ or they are located in the storage depot of a museum. With the knowledge that museums often don't allow the transportation of these fragile windows to an external lab, the need existed to bring the lab to the depot of the museum. And for that, we use portable or transportable analysis equipment, and in our case, these are portable optical spectrum analyzers. In our most recent research, we have focused on the study of the silver staining technique. It is a technique which is used to color certain parts of the window, and it has certain benefits compared to the alternative coloring technique, which is pot coloring or bull coloring. So the main advantage of the silver staining technique is that the glass artist could obtain a much wider color palette by playing on the technology parameters, while for the bull coloring, the color solely depends on the type of dye that was added to the glass matrix. The silver staining process consists of mixing a silver salt with a binding agent and to spread this mixture over an uncolored glass sheet at those locations where you would like to have the coloring of the material. Afterwards, this glass window is then positioned in a furnace, and upon heating up, a diffusion process occurs where silver ions diffuse inside the glass batch and are exchanged with the alkali elements inside the material. And then afterwards you have the formation of colloidal silver nanoparticles. What is important to know is that the size of the silver particles, distribution and also the penetration depth depends on the applied technology parameters. For example, the composition of the silver salt, the composition of the binding agent, the furnace temperature, and also the duration of the baking process. To study those nanoparticle distributions, people typically make use of high-end transmission electron microscopy. So this is definitely a device that you cannot bring to the depot of the museum. Now, fortunately, photonics can bring a solution there. So when we illuminate the sample with light, two phenomena take place. First of all, you have surface plasma resonance at the surface layer, so where the density of the nanoparticles is the highest. And secondly, you also have light scattering. So we have seen with our research that when we study the profile of the absorption and the transmission spectra in combination with the calculated color, that we can unravel the technology parameters that the ancient glass workers applied. All the details of our research are reported in a scientific paper that we published last year in the Journal of Non-Crystalline Solids.